All right, this question I know is going to cause some problems. Percentages in general on the SAT are very tricky because percentages are just very hard to think about. Our brains are just not equipped to think about them in a very good way. So we need some sort of system to make sure we can sort through all the information. Plus, at this point, we're at number 21 out of 22. We know this is a hard question. Even the easy module, we're going to get some hard questions that are just hard for everybody. And I think this is hard for me too. But what I'm going to be able to do here is keep organized using both a formula and some real numbers. So let me show you what I mean here. Let's start with the easiest thing. I'm going to arithmetize to make my life easier. The number A is 60% greater than the positive number B. Okay, so because I've got some sense of how percentages work, I want either A or B to be 100 because 100 is a nice number for percentages. It just works out really well. I can do some math in my head. So what I'm gonna do is make B 100. Because then I can easily say, okay, well, 60% more is going to be 160. So the number A is 60% greater than the positive number B. In other words, 160 is 60% greater than the positive number 100, okay? So we can prove that using the open formula. And in this case, we're going to need to use the open formula that uses the 1 plus or minus p as a way to show that it's an increase or decrease. Because you can tell from this question, greater than, less than, these are words that tell us there's a percent change. And so we need this formula that gives us the percent change. Now, original, the O is the original value. The P is the percentage, and the N is the new value, right? So we have to think here, this is what makes it a little tricky. Which number, A or B, is the original value here? Well, it's B because A is based on B, right? A, we only understand A because it is 60% greater than B. And this is a real clue that we can use for all sorts of percentage questions. Words like than are pointing to your original value, right? So they're telling us that basically than the positive number B means that B is my original. So another way to write this using this formula is that B times 1 plus 0.60, the percentage needs to be as a decimal, is equal to A. And now it makes sense that if I made B 100, 1.6 times 100 is 160. So all my numbers work out. So I've got A, I've got B, and now we can do the same thing, but let's get C. The number C is 45% less than A. So now when we use our open formula, we have to do A is my than, right? So if I follow that, that same logic I used before, then A is now my original. So this is what makes it tricky, is it's kind of switching it up. So A is my original, and 45% less, don't get fancy here, less means we have to minus, and so 45% less means it's going to be the 1 minus 0.45, and that is equal to C. So we have A, that's 160, we already made that up by arithmetizing that number. 1 minus 0.45, let's grab the calculator, 1 minus 0.45 is 0.55, and that is equal to C. So 0.55 times 160 is 88. So there you go. Now we have a value for C, we have a value for B, and a value for A. And what do they want here? The number C is how many times B. So we can convert that into a, I guess, equation as well. So C is how many times B. Now notice what I did here, as I kind of just followed the words. Is another way of saying equals, how many is kind of a way of saying X, and then times B. So we're literally just looking for this X. We have 88 is equal to X times 1. Oop, nope, that's A. See, be careful. This is why with arithmetize or any sort of situation, we have to label what we've got. So 88 is X times 100. I already know the answer, but we can just divide by 100 to solve for X. It's getting a little messy here, but that's going to be 0.88, 0.88, and that is my answer. This is a tricky question, so if you had trouble with this, don't feel bad. This is near the end of the module. If you wanted to, you could have easily skipped this and gone to 22, but I do think that when you get to percentage questions in general, you're better off starting things off by just writing one of the two percentage formulas. We have the basic open formula that just looks like the word open without any sort of weird pluses or minuses. That's used when we just want to take a normal percentage of something, like 13% of 22. That's a normal percentage. There's no percent increase or decrease. And one of the biggest clues that we have, the weird open formula with the plus or minus, is words like than. They're telling us that we're changing, that it's a change in percentage. And so we need to adjust that using this formula. It is a tricky question though. So again, I don't feel bad if you got it wrong, but because I was able to arithmetize and pick a number for B, or A, wouldn't have mattered either way. I was able to kind of think about this without having to deal with lots of algebra. Some of you can do this with all algebra and just keep those A, B's, and C's throughout. But for me, that's very, very difficult to do. That gives me way too many things to think about. So by picking a number, even if it's a random number, I at least have a number to look at and work with and plug into a formula. Because remember, at the end of the day, our main formula for math is to plug points into equations. In this question, it is hard. We did the exact same strategy, plug points into equations. We got the equation from our memory because we knew we needed the open formula. We needed an equation that was associated with percentages, and we got the points from just random guessing because we needed points to plug into that equation. And remember, with percentages, 100 is a nice number, but I could have picked any number and this still would have worked out. That's the power of arithmetize. I have lessons on this strategy that you can watch on my channel, but basically it is a great strategy for just getting rid of algebra and turning it back into arithmetic, which is much easier for our brains to understand.